As we learned in the last class, the whole purpose of this course is functions. And we said that a function is a rule or a pattern that turns an input into an output. That's what we're doing all year long. We're looking at patterns. The first pattern that we're going to talk about, we've already started, is absolute values. So what happens when you try and take the absolute value of a number? And the input is the number you're taking the absolute value of. The output is the result. What patterns are we going to find? What we're going to do throughout this year is to start looking at patterns, to investigate what kind of patterns we can find. We're going to pick a bunch of numbers and see what happens when we actually do the thing we're trying to do to those numbers. You did this in Algebra 1 too, called it a table of values. The idea is we have a bunch of values to plug into the function, and we'll see what the outputs are. This part is usually pretty easy, but what it allows us to do is then graph the results and identify any sort of patterns. So let's take a look at the table. We know that if you put a -3 into an absolute value, and let me just stress our function is the absolute value of the input. F of x is equal to the absolute value of x. If we take the absolute value of -3, we get 3. If we take the absolute value of -2, we get 2. If we take the absolute value of -1, we get 1. If we take the absolute value of 0, we get 0. I'm going to pause here. I said 0. I'm going to pause here and start graphing those points. So what it means to look at a graph of a function is you're looking at all of the pairs, we call them ordered pairs, of inputs and outputs that go together. Almost always we'll put the input on the x-axis, on the horizontal axis, and the outputs on the y. And so when the input is -3, the output is +3. We'll graph that as a point right here. The input of -2, the output is 2. The input of -1, the output is 1. The input of 0, the output is 0. And you can see there's a clear pattern going on here. We can clearly see that the graph is a straight line. And we can figure out that it would keep going. So I'm going to put an arrow on the edge of it. But here's where it gets interesting. It looks like our graph would keep going this way and keep following that pattern. But if we look at what actually happens when we start plugging in more absolute values, the absolute value of 1 is 1. The absolute value of 2 is 2. The absolute value of 3 is 3. And those points don't continue along that pattern. They form a new pattern, which we can imagine would continue. The absolute value of 4 is 4. The absolute value of 5 is 5. And so what happens is from that point 0, 0, we can see we start following a new pattern in that direction. When you look at this graph, your job is to be able to recognize what's happening here and then find a way to describe it. So I want descriptions to be as specific as possible. So I might say in this graph, well, the input, I'm just going to say x, is less than 0. The output is decreasing at a steady rate, or a constant rate. And we learned in our last class, this idea of decreasing at a constant rate is important. The word for that is linear. This section right here is linear. That's why I'm going to make sure to include the words at a constant rate in my description. And I can continue starting from when x is 0. The output begins to increase at a constant rate. Now, there are lots of other ways you could have phrased this, but the important ideas that I want you to remember from this is that the function is first increasing, or first, in this case, decreasing, and then increasing. So that's really important that at some point the graph turns around. In fact, there's a name for that. It's called the vertex. The vertex of this graph is at 0, 0. And also, it's important to point out that the rate at which the graph is decreasing and then increasing is a constant rate in both cases. That's important. Those are the two keys here. And that gives us the shape of our graph. You want to think of that as just like it looks like an absolute value, v. And then using some of the vocabulary we learned last class, we can talk about the domain and the range. The domain is the easy one, and the domain is for most of the year going to be the easy one, because more often than not, the domain is going to be all real numbers. You can take the absolute value of anything you want. So we'll say all real numbers. And the range in this case, well, the only outputs you're ever going to get from the absolute value of a number are numbers that are 0 or bigger. So we're going to say y is greater than or equal to 0. And that's our range. I will introduce a new way of saying this. It's called interval notation. And I don't care whether you use inequalities or interval notation when you answer questions about domain and range, but you do have to be comfortable reading both of them. And if you see both of them, you don't get confused. Interval notation is a way of describing ranges of numbers or series of numbers by describing their beginning point and their end point. When we read interval notation, we'll always use the language from some number to some number. We're always going to use that sentence structure. When we write it down, we're going to be a little bit more specific. It's only going to show up in how it's written. But if we look at the range as y is greater than or equal to 0, because 0 is included in that, we're going to use a bracket to show that 0 is included, and to show that it keeps going forever and ever and ever, we will say from 0 to infinity. That's what's called interval notation. Notice how parentheses is always used around an infinity sign, because you can never get up to infinity. You can never include infinity. It's not a real number. So that's why we say from 0 to infinity, we are including the 0. We are not including the infinity. For all real numbers, we would just say from negative infinity to infinity. And that's how we write all real numbers using interval notation. We'll see more with interval notation as we go through the year, and you'll get more comfortable with it as we go. One additional quick note is we can graph absolute values on Desmos also. Just in case you're not used to it, I'll show you. There are two ways you can graph absolute value on Desmos. One is with the vertical bars, just like the absolute value symbol. On your keyboard, if you look above the Enter button, you'll see a backslash and a vertical line. That vertical line is the absolute value, or can be used as the absolute value bars. So if you press Shift and that, you can see that vertical line appears, and you can type what you want. Notice how in Desmos, when you open something like a parentheses or an absolute value, it automatically closes it also. So all I need to do is move outside of that. If I want to, I can close it myself, but it was already there. And there's the absolute value view we graphed. Just in case you ever forget where that absolute value bar is, just so you know, you can also graph absolute value using the letters A, B, S, and then open up parentheses. That'll also graph the absolute value of x. So that's two ways you can make Desmos graph an absolute value.